Alright guys, so before we move on to our next graph of hyperbolas, we're going to look at the idea of limits. So I like to think of limits as zooming in on a point, and like you're pretty much looking at where the height of it is. So you're looking, so if it's x and y, you're looking at how high, like the y value of the graph. And some a little notation thing. So you notice here a with a little minus on it. That just means that we're looking from the left of a. And obviously the plus means we're looking at the right side of it. So before we start looking at it, another definition thing. So a limit fails to exist if the limit from the left and the limit from the right aren't equal when we're looking at piecewise functions. Alright, so let's look at our basic hyperbola, 1 over x. So what this means is the limit as x heads towards 0, so the plus means we're looking at the right side of 0. So the x value is 0, and on the right side is around here. And now we're looking at the height. So here you can see it's going up forever. So we just say infinity. So 0 with a little minus on it, so the left side of 0. So the graph you can see on the left side of 0, it goes towards negative infinity. As the graph heads towards infinity, so as it's going positive numbers forever, you can see it gets closer to 0. So we just say 0. And if we put a 0 plus, that means the positive side is 0, so that means on top. And obviously the other way, you can see it's towards 0, but it's on the negative side, so you can say 0, a little negative. So yeah, we can see that graphically. Just think of limits as where the y value is, pretty much. So if we analyze this harder graph down here, we can see that the limit as x heads towards 3 negative, on the negative side heads towards infinity. So 3 on the left of it heads towards positive infinity, but on the right side of it heads towards negative infinity. So yeah, while we have the graph here, let's just get used to analyzing the limits. So as we can see, as x heads towards infinity, so as it goes towards this way, we can see it heads towards asymptote. So it's never going to cross this line. So we see y heads towards 1, but it's on the bottom of 1, so it'll be a little minus. And we can see that it'll be the same thing for here as well. So as x heads towards negative infinity, y would head towards 1, also on the negative side. So yeah, so if we went so normally we analyze all the asymptotes as well. So if we did x heads towards negative 1 minus, so on the left side of it heads towards negative infinity, on the right side of it towards positive infinity, like the one we've shown on with the 3. So yeah, that just gives you an idea of what limits are. So yeah, let's actually calculate limits. So the most basic method you want to try is always substitute in the x value first. Normally the questions won't work out, so normally you have to factorize and then cancel, and you can sub it in. So I'll show you why later. And then for the harder ones, for limits going to infinity, I just like to just put in a high number, or a really high number, or like it's negative infinity, a really low number, and then you can see where the graph heads towards. Yeah, so another thing to note is 1 over x, so 1 over infinity, it gets a really small number, so it just pretty much becomes 0. But yeah, let's just do the questions. So limit as x heads towards 3 of 4x. So the most basic thing you want to try is just sub it in. So we can sub in 3. So that means that 3, the graph y equals 4x would head towards 12. So we can actually do this one as well. So we'll sub in the 1. And we should get 4 plus 5 plus 2, which is just 11. So for the next one now, notice if we sub in 5 straight away, we get 0 on the denominator, and that's impossible, so we can't do it. So that means you have to factorize and cancel first. So a nice thing about these is, it pretty much tells you that x minus 5 is going to have to be a factor. So that just gives you a hint for when you actually do your solving quadratics. So if we were to solve that using our L method, two numbers at times to give us negative 35 and add to give 2. And obviously here it gives us a hint that negative 5 is going to be one of them. And then we can say that's going to be negative 5 and 7. So then x minus 5, x plus 7. So now we'll cancel the x minus 5, so you're left with the limit x heads towards 5, and then x plus 7. And now you can note that now we can just sub in the x equals 5, like before. So it'll be 5 plus 7 equals 12. Alright, so the next one, it's just a bit more algebra. So first thing I'll do is just get a common denominator. So 1 over x plus 4 and then 4 on the bottom. So the common denominator will be 4 bracket x plus 4. So x plus 4, you need to times it by 4, so that'll be 4 on top. And then make sure you keep your brackets because there's a negative here. And that means to make this the common denominator, we're times by a factor of x plus 4. So make sure you keep your brackets so that you don't get confused with the signs. And then dividing by x is the same as timesing by 1 over x. So if you remember your old fraction skills, when you divide, you change it to a times and you make the reciprocal. So now we'll simplify this. So 4 minus x, and that'd be minus 4. So the 4's will cancel, you're left with x on top. And then it's going to be 4 times x, that'll be 4x, and then x plus 4. Then we can cancel out a factor of x, so limit as x heads towards 0. So we know we've got to factorize out or cancel out because we still can't sub x in the bottom. I mean x equals 0 in the bottom. So you're left with 1 over 4 x plus 4. And if you sub in the 0, you're left with 1 over 4 times 4, so you have 1 over 16. Alright, so next one, limits x heads towards infinity of 2 over x. So remember as I said before, if it's like something over x heads towards infinity, head towards 0. So I'll just show in the calculator. So 2 over a really big number. You can see that it's really small. And if we make it the number bigger, it gets even smaller, so it's pretty much just heading towards 0. So we can say that's 0. And the next one is x towards negative infinity of x over 2. So you're pretty much getting a number and you're halving it. And it's pretty much, you can see it'll be like if we do it on the calculator. you do negative 99999 over 2. We get that. If we make it even bigger and add in a few more 9s, you can see it's just getting bigger towards the negative direction, so it just heads towards negative infinity. Alright, so now we're going to have a look at harder limits. So you can't factorize it and it heads towards infinity. So we're going to use a divide method. So this is a bit more of an extension type question, but I'll just show you anyway, just in case you come across it. So yeah, if you get this question, x squared minus 5x plus 2, you get 3x squared minus 1 at the bottom. We can't really factorize this and cancel out. So what we do is we divide each term by the highest common power of x in the denominator. So in this case, it's x squared. So we divide through by everything by x squared. So yeah, make sure you do every term on both the denominator and the numerator. And yeah, so it's similar to the other one. So anything over an x, we just head towards 0 as it heads towards infinity. So that's the main idea we're trying to get at. So yeah, these will become 1. So I should write another step of working out. So yeah, just simplify it. So now as x heads towards infinity, all these ones that are over x, they're going to head towards 0. So it's pretty much you're left with, the graph heads towards 1 over 3. So yeah, that's how you do the harder limits. I'm now going to have a look at a quick idea of continuity. So a function is continuous at x equals c if, so fx is defined at c, the limit of x heads towards c at fx exists, and fc is equal to this limit. So pretty much 1 and 3 are equal. So graphically, we can say that this first graph here is continuous. This second graph, even though it has a sharp point and it's not smooth, a limit at that point exists. The third one, there's an asymptote there, so this is not continuous. And here there's a broken point there, so that's not continuous either. So yeah, let's do these questions, and you will notice that there'll be a point of that it's not continuous. So obviously from looking at this graph, we know that x cannot equal to 1 because it will make the denominator 0. So let's find the limit of it. So we know that in this case we're going to have to factorize out. So x squared minus 1 is the difference of 2 squares. That's x minus 1, x plus 1. So we'll know that we can cancel out. And then we just sub in after. We'll get 2. So we know at that point it heads towards 2. So pretty much you can see that if we simplify this equation now, suppose y equals this graph, we can break it down to x plus 1, but we know that x cannot equal to 1 because of the denominator. And x plus 1 we know is just a basic straight line. So at that point, 1, 2 there, we know it's going to be broken. And x plus 1, so that's a straight line, it cuts at 1. And when y equals 0, x equals negative 1. So yeah, it's pretty much a straight line, but it's discontinuous at that point. So the equation of this line is y equals x squared minus 1 over x minus 1. So you guys can try this next one for yourselves, and I'll put the answer up for you. So pretty much use a similar method